Suppose you're asked to solve this equation, 6 tangent x plus 2 equals 2 tangent x minus 3, where x is between 0 and 360 degrees. So again, we've got a trig equation that involves only one trig function, and that trig function is always raised to the first power. So it's a linear trigonometric equation. And here again, the first goal is to isolate the trig function. When it appears in the equation more than once, a good first step would be to combine those like terms. So I'm going to subtract 2 tangent x from both sides here. So the 6 tangent x minus 2 tangent x will leave me with 4 tangent x plus 2. The tangents are gone on the right-hand side, so I just have that negative 3. Alright, so continuing to focus on isolating tangent x, I could now subtract 2 from both sides. So 4 tangent x equals negative 5, and then finally divide both sides by 4. Okay, so now I've got the trig function by itself. The problem is, if you look at the values of tangent on the unit circle, so if you look at the ratio y over x on the unit circle, you're never going to see a ratio that's equal to negative 5 over 4. That just doesn't correspond to one of the standard angles on the unit circle. So if you are looking for a value that does not appear on the unit circle, then you should grab your calculator. And now we're going to have to approximate the solution. That means, once you grab your calculator, you're not going to find an exact solution. Most likely it's going to be an approximation. Let me get a new page here. So we are here. Negative 5 over 4, right? All right, so to find one solution, we could, the first thought might be, all right, I want to isolate x, so I want to get rid of the tangent, so let me do inverse tangent to both sides. And inverse tangent of negative 5/4 will help us find the solution, but it's not as direct a path as you might think. So using the calculator, we can approximate inverse tangent of negative 5/4. Make sure that your calculator is in degree mode here. Okay, but grab the calculator. I have a value of negative 51. I'm going to go ahead and take an extra decimal place with me here. So negative 51.34 degrees. Now remember that the problem asked for solutions where x is between 0 and 360 degrees. So this doesn't do it. That's not in the interval that we're looking for. So think about an angle in standard position. The calculator gave us this solution, so negative 51.34 degrees. But we want the solutions between 0 and 360 degrees. So one thing you could do is add a full rotation. So add 360 degrees to that, and you get 308.66. I think that the instructions in the original problem might have said to round to the nearest tenth, so I'll round that to 0.7, 308.7 degrees. And there's one solution. The thing is, there's another solution. So let me draw the x and y axes one more time. If we think about where is tangent negative, so remember that's the ratio y over x. This is supposed to be a question mark right here. Y over x on the unit circle. Over here, x and, let me get my pointer. Over here in the quadrant 1, x and y are both positive, so tangent would be positive, so we don't want that. Over here, y is positive and x is negative, so y over x would be negative. So there will be a solution here in quadrant, oops, that's not here in quadrant 2. Moving around to quadrant 3, here x and y are both negative, so y over x would end up being positive, negative over negative. Here in quadrant 4, x is positive, y is negative, so the ratio will end up being negative. So there is a solution in quadrant 4. And actually we found the solution in quadrant 4. It's right there. It's the 308.7. But we need to find the solution in quadrant 2. And the way you do that is using a reference angle. So that, sorry about my text messages. All right, so if you set up, go to this solution that we found with the calculator. If you pick up that angle and set it down in quadrant 2 as a reference angle, so think about setting down the 51.34 degrees here. Then the quadrant 2 solution would be this angle right here. So it's using reference angles, but that quadrant 2 solution would be, well, if the entire upper half of the unit circle is 180 degrees, then to find this angle in black, I want 180 degrees minus that reference angle, 51.3 degrees. And so we find a solution in quadrant 2 of 128.7 degrees. And there are our two solutions between 0 and 360 degrees. Again, we find two solutions because we know that tangent is negative in two quadrants, quadrant 2 and quadrant 4. And we found the solution between 0 and 360 degrees in each of those quadrants.